example, we will do a limit comparison test example. All right. So suppose you have the example n equals 2 to infinity n squared over n to the fourth minus n minus 1. And in these types of examples, when you have polynomial, rational fraction, rational function, we can ignore the lower terms and see what this is close to. So compare with, do we agree n squared over n to the fourth minus n minus 1? This looks similar to n squared over n to the fourth. Well, how can we reduce n squared over n to the fourth? That's about 1 over n squared. So we can actually compare with the sum n equals, going from 2 this time, 1 over n squared. Well, we've done this problem a bazillion times here. Here p is equal to 2 greater than 1. Therefore, this converges by the p-series test. And now we can do the limit comparison test. What does the limit comparison test say? If we take the limit as n goes to infinity of, and I like to write it as given over chosen. So the given part is n squared over n to the fourth minus n minus 1 divided by chosen, which I said was 1 over n squared. Now, dividing by a fraction is the same thing as multiplying by the reciprocal, so let's do that. This is the same thing as n squared over n to the fourth minus n minus 1 times n squared over 1. That's going to be the limit as n goes to infinity of n to the fourth over n to the fourth minus n minus 1. And we see that since the numerator and denominator, the highest power is just n to the fourth, we can divide the coefficient, and the limit is 1. And the two things we need to check, is this finite? Yes. Since this is less than infinity, and this is positive? Yes. It's greater than 0 and less than infinity. Because it's finite and positive, it has the same convergence or divergence as what you compared with. And because 1 over n squared, the sum converges by the p-series test, we can say, therefore, this series also converges by the limit comparison test. And that's it.